Hello and welcome back to the course on R programming. And today we're going to finally get to analyze the NBA data. I hope you're pretty excited about today's tutorial. And to start off, what we're going to do is we're going to have a look at what we created last time, because that is going to help us a lot during today's tutorial. And last time we created our own very first function. This function is called myPlot, and it requires two parameters, data and rows. The first parameter is compulsory, makes sense because our function can't operate without any data, and rows isn't compulsory because it has a default value, so if you don't supply the rows that you want to visualize, it'll just visualize all of the values. Now here you can see what this function does. It takes any data that you supply and it replaces it over here, and the rows that you supply get replaced here and here as well. And so what the function does is it first subsets the data that you supply based on the rows that you require, and here we're using that very important feature of subsetting in R that we talked about in one of the previous tutorials. Then we are plotting the data with the matplot function, and we're using the legend function to create a legend. And so here I've got an example. I'm going to plot the games of the top 10 paid NBA players for the past 10 years just by running this one line. And as you can see, there we go, that's a plot. So now what we're going to do is we're going to move on to analyzing and driving insights. And I'm going to go to this new tab. So I've prepared some code here already, and I invite you to follow along. So as we run these lines, just code them up in your R Studio. I decided not to write them up one by one because we're kind of moving now from the stage where we're learning R and learning all these things that we need for this analysis to actually performing the analysis. So the focus today is going to be on analytics and on data science and, doing the analysis in smart, thought through way. So that's what we're going to be talking about most of the day today. So let's get started. myPlot salary. What are we going to plot here? First thing that I was interested to see was how have the salaries of these players been changing? So how did they actually get here to be in the top 10 paid players? As you can see, Kobe Bryant was always quite up there, and his salary has been growing up until the previous season, 2014-2015, and his record was over $30 million for 1 year of playing. And then here we've got the rest, so you can see that Joe Johnson started quite above, but then the rest caught up with him, and now they're all sitting over here. So that's how the salaries have been changing. Now let's plot how much they get paid per game. So salary divided by game. And this is where I first ran into this conundrum that we've got some anomalies here. What happened here? So who's this? Kobe Bryant and Derrick Rose. So why are they getting paid so much per game? As we saw previously, their salaries are comparable to the others. Well, the reason here is that both of these players were actually injured in that 2013-14 season, and that's why per game they didn't play that many games, so their salary per game is quite high. And same thing, salary per field goals. So what we could do from a data analytics point of view, we could remove these anomalies and then continue with analysis. However, digging further into the basketball data, I found that these players put so much effort into their game that they get injured quite a lot. So we would see discrepancies like this throughout the whole data set, and moreover, where we wouldn't see them, they would be still skewing our data without us knowing it. So therefore, visualizing salary and in-game statistics together might not be the best option. And the reason for that is that salary is not affected by injuries, whereas in-game statistics are. And so the players get paid regardless of whether they're playing or not. They have contracts, but their statistics such as games played, field goals, and so on, they do get affected. So from an analytical point of view, unless we can somehow exclude those the effect of injuries, we shouldn't visualize salaries and in-game statistics together. So let's go and look at the in-game metrics. Let's plot the minutes played. And what do we see here? Well, here we see how many minutes each of the players played in the past 10 years. Okay, and let's plot points. So what we see here is another thing. Like, we know that Derrick Rose is, for instance, a great player, and he was MVP in 2010-11 season. But here we can see that the points that he brought to his team dropped over here. And so same with Kobe Bryant. But the reason for that is that both these players were injured over here. So once again, we can see that injuries are affecting our visualization. So how do we fix that? How do we approach it as data scientists, and actually how do we take injuries out of the equation? Well, we know that injuries affect all in-game statistics, right? So if you don't attend a game, you're injured, you don't attend a game, but you also don't score goals. So what we can do is we can normalize in-game metrics by in-game metrics. And that's what I have here. So if we take field goals and divide them per game, rather than just plotting field goals by themselves, if we plot that, then you will see that now we can actually compare them. So even though some players were injured, some players were not, you're calculating how many goals is scored per game, so actually per game that they attended. Now, injuries do sometimes affect, and quite often affect, players even when they're playing, but already we're extracting, or we're mitigating some of that effect that injuries have on our visualization. And so now you can go ahead and compare the goals per game that players score, and as you can see, back in the day, Kobe Bryant had a crazy amount of 13 per game, and now it's dropped quite a lot. And right now in the lead, we've got LeBron James with about just over 9 goals per game on average. That's not points, that's actually goals. Okay, and now let's visualize another normalized metric. Let's visualize field goals per field goal attempts. I think that one will be pretty interesting. So if we look at that, this is basically the accuracy of the players. So how many goals did they make divided by how many attempts did they make. So here you can see right away that Dwight Howard is up there, up at the top, and way above all other players in terms of accuracy. And he is the 5th highest paid player in the NBA currently. So what does that mean? Well, that means that basically out of the balls that he throws at the net, about 60%, nearly 60% actually end in a goal. So let's see how he's going in terms of actual attempts. So we know that his attempts convert very well, but how many attempts per game does he have? Let's look at this visualization. Here we see that Dwight Howard is actually at the very bottom, right? So he was at the top for conversion of, or successful attempts. Now he's at the bottom for the actual number of attempts per game. And therefore, it makes sense that he doesn't actually score that many points per game, even though that his accuracy is quite high. Because he makes few attempts, he doesn't score that many points. And so that's an insight we could derive right away. And probably basketball people with a lot of knowledge about basketball could comment on this and could say why exactly he doesn't make that many attempts. Maybe he's on the court in a position that is not designed to make that many attempts. Or maybe it's not the case. Maybe he can start making more attempts, and then because his accuracy is so high, maybe he'll start scoring more goals. So that's something to look into. That requires more, as it's called, domain knowledge, so knowledge about basketball. Now we're going to move on to some more interesting observations. Let's say minutes played per game. So I thought this was quite interesting. You can see that the minutes played per game for these top 10 players has been dropping overall. So you can see the trend here, it's going down, and I couldn't explain that. I couldn't explain why. So I would understand if it was for 1 or 2 players, but overall these players seem to play less minutes per game on average as we move from earlier years in their career to later years, and that would be interesting to find out why. Okay, so at the same time, if we plot the games, you can see that they haven't, the number of games that they've been playing is actually pretty consistent. It's not that they're playing more games and therefore they're playing less minutes. They're playing pretty much the same number of games, but they're playing less minutes per game. So that's an interesting one. Okay, so time is valuable. Since they're less on the court, less minutes per game on the court, their time is valuable. Let's see who uses that time most efficiently. So who scores the most field goals per minute played? Let's run that one. And here we can see that it's actually Kevin Durant. He is quite young, and so when I was gathering this data, I noticed that he joined the NBA quite recently, like relatively recently. So he's young, and you can see that his goals per minute played have been increasing with time. So Looks like I've seen a few articles calling him the rising star, so we'll see how it goes. But so far the data does confirm that he's using his time on the court valuably, and that's what we're seeing. And also we're seeing kind of two groups. We've seen some players over here, and we've seen some players over here. So the players that fall into this group, Kevin Durant, Dwayne Wade, Carmelo Anthony, and LeBron James. Very interesting to see this type of grouping. And finally, one more interesting visualization that I found was points divided by field goals. So it's kind of player style. So in basketball, you can score a 2-point goal or you can score a 3-point goal. And also you'll see that some of the averages here are actually above 3 points. That's because our field goals or our points data includes both goals, field goals, and also includes the free shots that they get. So we would need to subtract the free shots points from points to exclude that effect. But unfortunately, we don't have that data in our data set. So let's just bear with this. We can still see that player style, player playing style is changing with time. So a good example that jumps out right away is Kevin Durant. You can see that first he used to score less points per field goal. So he was going for the 2-point shots more, and then he started scoring more points. So that means he was started going for more for the 3-point shots, or he was getting more free throws, and then it dropped and then went up. So it's interesting to see how some of the players have a change in style like that. Or Kobe Bryant, for instance, like the average dropped and then it started going up again. Or what's another one? Here we can see Chris Bosh. You can see that his average was dropping consistently and then started growing. So it'd be interesting to see what is the cause of these changes. Are there trainers telling them to change their style, or are there trends in the basketball sport that change over time? And things like that. It would be interesting to observe that. Okay, so there we go. That's some analysis of the stats that we have. And what you can do is you can take the similar approach and explore some other things, because there's so many things that we haven't explored yet here. You can just try and normalize different matrices by different matrices and plot some of these things and find some insights of your own and see what you're able to discover. I hope you found this tutorial interesting and exciting, and I look forward to seeing you next time. Until then, happy coding! Hello and welcome back to the course on R programming. Wow, what a section we just had. We learned so many things about matrices, and at the same time we had so much fun talking about the basketball data. And congratulations to you on completing this section of the course. It was quite challenging. There was a lot of things to cover, but because you're watching this tutorial, you've definitely gone through all of those things. And now we're going to just recap on what we learned. All right, in this section we learned. First thing, of course, we learned about matrices, and we discussed that a lot of the data in the world, if not most of it, is stored in table format, and matrices are one way of representing tables in R. Then we saw how we can build matrices. We learned about the matrix function, the rbind, and the cbind function. So the matrix function basically bends your vector into a matrix, whether it's row by row or column by column. You can specify that behavior. And rbind and cbind are way more commonly used because they combine existing vectors into matrices as rows or as columns. So as you can imagine, you would rarely bend a vector into matrix. You would more often have existing rows and you would want to actually combine them into a matrix, or existing columns and combine those into a matrix. So we talked about those three functions and we saw some examples. Then we talked about naming dimensions. So a concept in R where you can, for instance, for a matrix, not only just use the number of the row or the number of the column, you can actually give the columns and rows names and then address elements of the matrix through the names of the rows and columns. Very convenient technique, especially if you have quite a large data set. And also the same concept works for vectors. So you can have named vectors in R, and we also saw that. And then we talked about call names and row names, and those are the two functions that allow you to give your matrix those named dimensions. Then we discussed some matrix operations, and finally we moved on to the basketball data set. We were mostly talking about division, but as you now know, you can add matrices, you can subtract them, you can multiply them, you can perform logical operations. So basically, like we talked about vectorized operations before, same thing for matrix operations. R by default will perform the operations element by element. Next, we talked about visualizing with matplot, and there's a caveat that matplot is not the best tool for visualization. Further in the course, we'll learn much better tools for visualization, but nevertheless, we learned about matplot and how to use it in our challenge for this section. Also, we talked about the transpose function, so just the T function, and that was important because matplot requires a matrix, but it visualizes it by column. Our matrices were all separated by players, by rows, so we needed to transpose our matrices, and that's why we learned about the transpose function, which is just the letter T by itself. Then we moved on to a very important topic, which is subsetting, and we saw how we can subset a matrix out of a matrix, and we actually went a step further and we also saw how we can subset a single row from a matrix, or a single column from a matrix, or even a single element. So extracting a single element out of a matrix is also considered subsetting. And what we noticed there was a strange type of behavior that was not consistent throughout this subsetting process. So whenever we're using the square brackets to subset a matrix, we would get a matrix. But whenever we were using the square brackets to subset a single row, a column, or an element, we were getting a vector in return. And that was because of that trade-off that R has, that sometimes it's not just a programming language, it's a programming language for mathematicians and statisticians. So you've got the trade-off of being strict about programming and being agile about data investigation. So sometimes R guesses what you want, and in this case, it guesses that when you're extracting a single row or column, it's guessing that you want a vector. And that is why we learned how to alter that behavior, and there we learned about the secret argument called drop, which allows us to get a consistent type of behavior from R when subsetting. It's a very important feature, and as we discussed, a lot of our users go for years without knowing all of these things, so I'm very happy that we discussed them in this section already. And then we had another very interesting tutorial. We talked about creating our first function, and we created a function called myplot to visualize, to kind of consolidate all of the code that we were using to visualize our data sets. And it made our code much more succinct because it was from then on very easy to visualize things by just simply calling a function. And finally, we moved on to deriving insights, and we had a look at some very interesting things about basketball. So this tutorial was less about our programming and more about actually digging into the data, investigating it, and I'm sure it was quite fascinating to see all of those valuable insights we could derive about the basketball players just from the data sets that we had. So there we go, that's the recap for this section. Quite a big section and a lot of very important topics were covered off, but at the same time I hope you had lots of fun along the way, and that's what this course is all about, learning and having fun at the same time. And don't forget to do the quiz to have a quick self-assessment. And if you're interested in working a bit more with basketball data, I've got an exciting homework challenge prepared for you, and I can't wait for you to check it out. And I look forward to seeing you next time. And until then, happy coding! Hello and welcome back to the course on R programming. We had a very exciting section just now on matrices, and we talked about basketball, and now we've got the homework exercise for this section where we will continue talking about basketball. We will investigate free throws. Alright, so let's have a look. What is a free throw to start off with? Well, a free throw is a bit different to a field goal or a field goal attempt in basketball. A free throw, you can see an example here, is when there's like a foul that happened during the play, then that team that was the victim gets an opportunity to throw in a free throw or a couple of them, and basically every free throw in basketball is worth 1 point, and the player has to stand where basically this player is standing in this example. That's pretty much everything we need to know. So they're kind of the additional types of goals that teams can score. They're not just field goals that happen during the play. These are kind of like penalties in soccer, something like that. Okay, so now let's move on to the challenge. So you have been supplied data for 2 more additional in-game statistics: free throws and free throw attempts. You need to create 3 plots that portray the following insights: free throw attempts per game, so how many free throws have the players been getting per each game that they've been playing; accuracy of 3 throws, so that is similar to the field goal accuracy that we've been calculating; and player playing style, 2 versus 3-point preference, excluding free throws. So remember, we have already spoken about the playing style. We calculate the ratio of points to field goals, but then we said that it wasn't exactly the correct calculation because the points still included free throws. Well, now we have an opportunity to exclude free throws, and that's exactly what is being asked of us in this third part of the challenge. And the star here, or the asterisk, says that each free throw is worth 1 point, so that's important because then you don't need to multiply by anything. So basically a successful free throw is a point that needs to be subtracted. And the data has been supplied in the form of vectors. You will have to create the 2 matrices before you proceed with the analysis. So previously we were supplied code that created the matrices for us. This time we're only supplied the vectors, and we'll have to create the matrices. And that's good because that will give us an opportunity to practice binding vectors into matrices. Okay, so that's the challenge. Let's go have a look at where to get the data set. The data set is, as usual, at superdatascience.com/our-course. So if you scroll down here to section 4, matrices, you will see the homework dataset. That's the one we need. Also, homework challenge is the document that we just walked through. So now I'm going to go to our studio, and this is the file. Once you unzip it and open it in our studio, this is what it looks like. So once again, here it says that you have been supplied the vectors you'll need to create the matrices, some copyright and some other information, and then finally we've got the vectors. So we've got the seasons vector, the players vector, and then we got the free throws vectors. And as you can see here, there's no matrix, no code for the matrix. You need to populate this code on your own. So basically you need to find a way to turn these vectors into a matrix, and you're probably going to need a function, something like a bind function, to bind these vectors into rows. That's a little hint. And also for the free throw attempts. So once you have those 2 matrices, then just quickly check them and then proceed to calculating the desired statistics that we just talked about. So there we go. If you're comfortable with this challenge, then please proceed with it. It's pretty straightforward, very similar to what we've already done. And at the same time, you will find some very valuable and interesting insights. However, as always, I would like to give you a hint. If you would like some additional information on how to proceed, then stick around. And now I'm going to bring up the hints. Okay, so hint number 1, very simple hint. The matrix calculation for part 3 is points minus 3 throws divided by field goals. So it's quite straightforward. And what's going on here? Previously we just had points divided by field goals, and that wasn't exactly correct. But now we're just going to take points and subtract free throws, because we know that free throws attempts are the attempts that they made. Free throws are the successful free throws, and every free throw is equal to 1 point. So if we subtract the number of points generated by free throws, this is this matrix over here. If we subtract it from the actual points matrix, then what we have left will be the points generated only by field goals, right? So only by 2-point shots and 3-point shots. And then if we divide that by the number of field goals, and this matrix gives us the number of successful field goals. So if we divide the points generated by field goals by the number of field goals, then we will get the average points that the player got for their field goals in that year, right? And then we'll be able to observe the trends. So this is the matrix operation that you need for part 3 of the challenge. There we go. That's a bit of guidance for this challenge. And now if you're ready to proceed with the challenge, please go ahead. And otherwise, stick around and I'm going to show you where to get the fill in the blanks exercise as always. So we're moving on to hint number 2, which is our fill in the blanks. Okay. So we need to go to, once again, superdatascience.com, our course, and here, section 4, you'll see fill in the blanks exercise. So if you open that up, unzip it and open it in RStudio, it looks like this. So here I've prepared some code which you can populate using what you've learned in this section. And so this part creates the matrix. So this bit is basically what needs to actually go in here into where you're required to create the matrix. I've just put it in a separate file. So basically this is creating the matrix, and it's got all the comments here. Then you check the matrix, then you create the other matrix for the free throw attempts, and then you check the matrix. Then you need to recreate your plotting function because we'll be using that. Then you can just visualize the matrices just quickly. And then we've got the part 1, part 2, part 3. And I've actually put in a lot of comments this time because the insights are that interesting. And once you get to this stage, make sure to read through the comments, or just visit the solution for this section. It'll be at the end of the course, and there we'll walk through the insights together. They are quite fascinating as always. So that's all for this challenge. I wish you best of luck, and you are fully equipped with everything you need to know to complete this challenge. And I look forward to seeing you next time. Until then, happy coding.